Friday afternoon, you merge a tiny change. No tests fail, nothing crashes. Everyone goes home feeling good. Monday morning, finance messages the team. Account balances are wrong, not null, not negative everywhere, just wrong. No stack trace, no obvious failure. That bug wasn't caused by complex logic. It was caused by unprotected state. This is why encapsulation exists. In procedural code, anyone can change shared data at any time, and that's where chaos starts. Most people learn encapsulation like this: make fields private, use getters and setters. That explanation is technically correct and completely unhelpful. Encapsulation isn't about access keywords. It's about control over how data can change. It exists to give each object authority over its own data, not just to hide things. Encapsulation isn't about rules for rules' sake. Encapsulation exists to stop this exact kind of bug, the kind that survives tests and shows up days later. An object is not just a container for data. An object is a responsible unit. Encapsulation means data and behavior live together. The object owns both. It owns its data, and it owns the rules that keep that data valid. This looks careful. It even checks a rule. But the responsibility has already leaked. The rule lives outside the object. The moment anyone can reach inside and change state directly, the object loses control. And once an object can lie about its state, everything built on top of it becomes unreliable. This is the core rule of encapsulation. You don't give the outside world raw access to internals, you give it operations. This looks simple and it's dangerous. Same result. Completely different level of safety. Behavior can enforce rules. State cannot. Let's go back to that account example. At first, everything is clean. Money goes in through deposits. Money goes out through withdrawals. The account object guarantees something important. The balance is always valid. That guarantee is not optional. It's a promise. That promise has a name. It's called an invariant. An invariant is a rule that must always be true. A balance can't go negative. An order can't ship before it's paid. A user can't exist without a valid identity. That's the invariant. Encapsulation is how objects defend their invariants. Not with trust, with control. Here's how things went wrong. A second developer joins the team. They need a quick fix. They're under pressure. They see the balance. They adjust it directly. No validation. No checks. The system still runs. Tests still pass. But the invariant is gone. Encapsulation didn't fail. It was never allowed to exist. Most dangerous bugs don't crash your system. They put it into impossible states. Encapsulation prevents bugs by making illegal states unrepresentable. If state can only change through controlled behavior, then broken rules can't sneak in silently. That's not elegance. That's defense. It's like letting anyone edit a database manually. It might look fine until it isn't. This is another way encapsulation quietly fails in real systems. Fields are private. but getters and setters exist for everything. For example, an order exposes get status and set status. At first, it seems reasonable, but now any part of the system can do this. Set the order to shipped before it's paid. The invariant still exists, but nothing is enforcing it. Encapsulation isn't about hiding fields. It's about exposing meaningful actions. Pay, ship, cancel. If outside code can freely set state, the object can no longer protect its own rules. This is where encapsulation really matters on teams. If everyone can modify state, then no one truly owns correctness. Private state forces accountability. It says if this data breaks, this object is responsible. That clarity scales. That's why large systems rely on it. When encapsulation is done right, something powerful happens. You can change internals, optimize later, fix mistakes, and the rest of the system doesn't care. Because it was never allowed to depend on the internals in the first place. This is why mature codebases feel boring. And boring is a compliment. That's why well-encapsulated modules feel stable even as projects evolve. Before we close, it's important not to confuse two ideas. Encapsulation protects data. Abstraction hides complexity. Encapsulation answers, what are you allowed to touch? Abstraction answers, what do you even need to know? They work together, but they solve different problems. Think of driving a car. You press the pedal, abstraction. You never touch the fuel mix inside, encapsulation. In the next video, we'll focus entirely on abstraction, how you can use systems confidently without knowing how they work internally. Let's lock this in. Encapsulation is not hiding for style. It's protecting truth, expose behavior, protect state, defend invariants. If your objects can be broken from the outside, they're not objects. They're just bags of data. In the next video, we'll break down abstraction step by step and show how it lets systems grow without collapsing under complexity. What's the worst bug you've ever seen caused by shared or unprotected state? I'll see you in the next one.